Hello everyone, let's look at the solutions to the task number 1, leader element of week 78 from the weekly challenge. So the task reads, you are given an array at A containing distinct integers. Write a script to find all leader elements in the array, print 0 if none found. An element is leader if it's greater than all the elements to its right side. Good. So here's an example. So there are a few numbers, all different. And we scan the array from left to right. The first number 9 is less than already 10, so we do not take it. But the next element 10 is bigger than everything on this right side, so we keep it. The same story with 7. 5 is smaller than 6 or 1. Well, it's less than 6, so we skip it. And 6 is bigger than 1, we take it. And finally, we take the last element because it's bigger than everything to its right. Yeah, that's a bit vague. Maybe it's not really clear in the description, but we, according at least to this example, especially this example, we always take the last element, right? So there's the only leader element in this list. So we take the last element always, which means that probably we'll never have the chance to print 0, right? Well, yeah, except the situation when the last element is already 0, or if there are no elements at all in the array, but those are not the cases, which are very interesting. Okay, let's look at the solutions, and actually there are a couple of new names, or at least the names which were not there in the list of Raku solutions for the few weeks. So yeah, I could start with those, but I believe I will just miss some other names. So let me start with myself. So my solution is this. So there is some input numbers, and there's the loop. Actually, yeah, there are quite some, too many words maybe in this solution. It can be a bit more compact, but nevertheless. So what I'm going to do here, I'm looping over those elements, and in a single go using this method KV, keys and values. Well, basically keys are for an array are indices. I'm just taking both indexes and the values because I want basically both. So I want to print this value, so print this $V if this element is bigger than basically all other elements to its right. To express the elements on the right side, I'm using this array slice with the range of indices, starting from the next element after E. That's why we have hat here, and going to the end of the list. So basically that's the star. Well, yeah, maybe in Python you don't need all these things, just a colon, and it will go to the end. But yeah, here you have to do that. Okay, so that's so simple. So maybe we can run this solution. I believe it works. Raku 1. Yeah, so these are 10761, the things that we need to print according to the task definition. Okay, Jan Krnavek. So here in this solution, what we do, we start with a couple of tests with the data from the task. That. Okay, so yeah, I see. So there's comma, trailing comma to indicate the list. And leader element, there are two multi-versions of this function, multi-leader element, multi-leader element. The difference is, okay, so this one is, okay, so basically star plus is a slurpy thing with double star. Reverse is a Boolean flag. It's not required here, it's required here. And here the default value is true, and here the default, where star dot not. So this star, I believe this is referring to reverse, right? Not to this one, I hope. So basically, yeah, it's a bit difficult. Okay, nevertheless, maybe I can just copy this solution and run this and print something from there. So for example, here I want to print version 1 with maybe just say A reverse, right? And also here the same thing here, but this is the second version, right? Okay, let's run this. Raku T. I believe we need something, right? Like test. Right. So okay. So so this is about the second thing. This one, yeah. And this is about the first array. So first, the second multi-version was called because we are calling this one leader element without any reverse, but it was default to true. Here it is. Then the second version of the function was called. Okay, so let's start with this one. So first we reverse the data not in place, but just reverse. We create the new one, right? Then we apply the leader element and reverse it again. We saw this just in the previous in one of the previous solutions. But when we call it recursively, we can we always call a different one, right? So because, or maybe not. Actually, no, this one will be called because we just saw that, and I believe this is this is happening for the second example as well. Then you take this array, you create the triangular reduction with the maximum, so you just have a few. Okay, so because we start from that's smart. I mean, the use of this one, the triangular reduction operator with the max function inside it is quite smart, because we start with the end, right? Because of this reverse, so we start with the from the end of the array, we compute all the maximums from the right side, right? So the maximum for the rightmost element, then the maximum for the two rightmost elements, and so on until we reach the beginning of the array. Then we squish that. Squish basically what it will give you. So these are the maximums, and squish will only give you the same elements. So if you have two maximums, it's kind of unique, but it's not unique. I forgot what it's doing. Docs Raku. Hey, I believe it will remove all the things. There was an example there, right? So you see, so this is the input thing. Actually, this the after you comb the string, you've got an array of characters, then you squish and you've got these characters. So you preserve the order, but you only keep each character once. So basically this is what you get. And here, so basically you will not include the same maxima. That's okay. But I wonder what happens if for example I will have 10 here, right? It will say false, but got this, expected that. Okay, well, actually seems to be working, right? Because this one should be 9, right? So this 9 should be there, and it is there. Okay, good. So it works, and then we can go. The next solution is by Jason Messer, solution number 1. Here is the solution. So we have the arrays, and we are going to call the function for both of them. So the function is taking the array where all the elements are positive. Actually, it was not in the task, I believe, right? Leaders, we're gathering. What we're gathering? We're gathering and we are scanning all the indices. $r is index. We take the element at this index if all the other elements, which are less than the current element, and all those elements do not exist. But basically there are no elements on the right side which are less. Because whose size is so we we grab the elements, we get the list of them, and if this list is empty, if there are no such elements, then we take this array. So instead of maximum, we are trying to find the elements which are smaller than the current one, and just count them. Right. That's it. So so I believe this will work. Raku, not here. Raku, Jason Messer, Raku Ch1. The data is built in, and it works. Going next. Right, the next solution is by the person who we didn't see. At least I believe I didn't see when I started these reviews, but I'm really glad that it's here. There's one function which takes the argument from the command line. And here we're preparing the maximum. We're putting it to -infinity. Then, then we reverse this. We grab something and we reverse it back. And what we're grabbing the elements. So we are scanning the elements from right to left in the original data, right? We take it as $V, and if this $V is bigger than the current maximum, then we return true. Otherwise, we return false. But we also, when we return true, we also assign a new value to this maximum. That's smart. That's really interesting case when in this operator, traditionally you would just return a value, but you see, so here you can also assign something to this. Cool. Maybe I would remove these, because what's the point of introducing a single variable in such a small function? You can either use $_ or just $v, right? And maybe even these parentheses are not needed. But in the rest, this is really competent and really nice solution. I especially like this part of it. Okay, good. We have to we have to run this. Raku Ch1, and I believe I don't have I don't have it in the buffer, so or I can just scroll up, but I can go back and take some data. I want exactly the same data. Right, so the result is correct. Okay, so there were no doubts that it will be correct. The next solution is a solution by Mark Anderson, and here is the code. So we create a random array. So we pick 25 elements out of those numbers between 11 and 35, including both. No, actually, probably, right, and we just, first we print the array, then we get the maximum of that, and we are, so you see, so we are taking the last element to the result. I believe we have to reverse this one, right? Because we know that the last element should always be there in the result list. And after that, we will continue removing the last element from this array. And we will append it to the result, this n, right? If this result is bigger than the head. Ooh, why is it head? Results, because, oh wow, that's smart. So results head is basically the previous maximum that we found, right? So we don't have to reassign maximum, the currently found maximum, but actually last if n is maximum. Okay, so that's smart. I like this solution. So basically, so you immediately find the maximum, and you, of course you have to scan the whole array here, and you break the loop, this loop. If you found the maximum somewhere in the middle, there's no need to scan the rest. Right, but probably it doesn't make the solution faster, because you still have to spend some time on finding the maximum. But this part is really nice. Especially, this part, that the previous maximum is already there in the results, right? And it's the first value there. So let's run this. Raku, Mark Anderson, Raku Ch1. And what do we have to do? We have to do nothing, just press enter. So here's the data. Okay. So we have to scan it manually. So 26 is there. Actually no, so you don't have to reverse it. So 35 is here. And apparently, yes, because this is the maximum in the whole array. So it always will be in the first position. Then after that, this 30, which is also, and then 27 and final 26. It seems to be a correct solution. Wow, that's, so this one is really a good thing. Good, going next. The next solution is by Richard Park, Raku number 1, and here's the solution. So say hello. Hello, lead element of the elements, and there's default. This is basically, by the way, how you can make the default array, right? That's cool. And after that we have something. So that's the lengths, that's the place for the results. Probably we don't need these, right? Then we scan the input data in the element. So these are the elements on the right side, right? Because we manually increment the current position, the index. And if this element is bigger than E, what is E? This one. Wait, no. Elem is, what is $elem? $elem. I don't see it, or $elem is the current element, right? So if the current element is bigger than the one of the items on the right side, then we append 0. Okay, if the number of these zeros, right, is the number of the elements which are greater is something. Then we append the... Okay, so yeah, I don't understand this part, but I believe it works. Otherwise, it would be strange. Richard Park, Raku Chair 1, and there's default something. Hello. So I don't know if it's solved correctly. So 10621, right? So but it's 10761, right? 10. It's the same, right? So 10. Yeah, here is the 10. Then 7 is bigger than. Yeah. So I think something is a bit incorrect. Okay, but nevertheless, yeah. So yeah, from this solution we can learn that you can use the default thing, express it like here. Cool. Okay. Good. Going next, Shahed Nooshmand, Raku 1. Wow, that's cute. So there's some data, say, and so we immediately print the result, gather 4, 8, and only take if. Ooh, cool, after. So you know what? I wanted to show what this after is. Where is it? This one. So the thing is that after, yeah, it's basically like greater, but bigger or whatever. Generic Lola use the same semantics as CMP. So this compare thing, it's a smart comparison operator which understands whether we are talking about the numbers or the strings. So in Raku we don't have to distinguish between what is it, like EQ, G greater GT, later LT, and ASCII graphics. So you can just use this CMP, and the language will understand and will do the right job for you. So yeah, so basically if this one is bigger than all of, ooh, wow, the bare dollar, so the variable that I can use when you create some one-liners. So we increment this counter, and basically, right, so how often are we going to increment it? Basically, I believe we will increment it each time we are inside loop, right? So maybe, so first of all, let's run this solution. Let's run this. That's an interesting solution. I really want to see that it works. Raku chair 1, and it works. And now I want to play with that a bit. Well, I want to do it like this if I can. Raku T. Oh, I copied only part of this for some reason. Right, let's create the full program. Right, okay. Yeah, any. I don't know how to access this one. 1, 2, 3, 4, 5, 6. I believe. So okay, but when we are here, when $_ is this one, so I believe this one is. That's I don't understand that. So I don't understand when this one is incrementing. So, but in any case, for example, if this $_ is 10, right? Yeah, at this position. So we have to compare this $_ with this range, which is basically this one. So we have to increment this $_ the dollar variable every time, right? Okay, this is your homework to understand how to work with this variable. But it's cool. Yeah, I like it. But nevertheless, let's go next. Who was that? That was Shahed. And where am I? I'm lost. Alright, yeah. So Simon Proctor, Raku number 1. Right, so what we are going to do here, we are taking the array where all the items are integer, and then we map through this, and we get the keys and the values, basically the indices and the values. And if the value is bigger than everything else on the right side, right, so this hat just gives us the next element, then we take that, otherwise we take empty, and after that we just print this one. Boom. Yeah, so simple and so straightforward, but it's already a very Raku solution. Raku Simon, Raku chair 1. Nothing is printed. Let's see, so we need some data. And okay, here are our data. Here it is, right? Yeah, okay. So yeah, so it gives the correct result. Okay, going next. And the next solution is by Arne Sommer, Raku number 1, with leading elements. Okay, so again, we are reading elements from the command line. They should all be integers, and while, okay, so we are going to shift the data from the array. So while we have some data there, we push it to B, to the result, which we're going to join, comma separated, in print, and we push if this element is bigger than all of the elements which are currently in the A. Yeah, that's also an interesting solution. So we remove the element and all the rest is okay. So right, Raku, Arne, Raku Ch 1, and again I want this, and the result is the same. Good. The next solution is by Athanasius, and his solution is here. Right, so there's some note. If A contains a single element only, then element is trivially greater than right. The array is specified to contain distinct integers, since 0 is an integer. A correct solution could be right. So this is what I told you in the beginning. But an empty array is still an array, and therefore a legal input. Further, an empty array is the only input for which no leading element can be found. That's right. Since an output of would be identical to the output for an array with 0, and as explained before, I have departed from the specification and put. Okay, so yeah, we want to distinguish the cases when the array is 0 and the array is empty. Right. So the solution is really short again. So we want defined integers in the input. And we want to make sure that they are all different. Was it in the ticket? I don't know. In the ticket, in the task. Then leaders, we are scanning the input data. We are scanning the elements on the right side of the current element, and we break the loop, the inner loop, if the current element is bigger than if the element is bigger than the current element, and otherwise we just push it. Right. Okay, so yeah, we can run it. Raku Athanasius Raku Ch 1. I have this here, and right, so here's the correct result. Right, 10, 7, 6, and 1. Okay. Solution by Colin Crain, Raku number 1. Here it is. Working from the end, the tail element is by definition the leader of none. From there, a running local maximum was okay. So yeah, that's a smart thing. So yeah, and probably this is the most efficient way of doing that, because yeah, you don't have to rescan the array again and again. So if we're going from left to right, we have to determine a maximum for all the elements, and some of the elements are in the same loop, will appear in the same loop a few times, right? So, but if you go from right to left, you will have no such cases. Okay, so we reverse the array. So we input this data from the command line. If there are no elements, then we will execute this part of this end thing. Right, so maximum, first we start with minus infinity, then we start with basically from the right side, we map. But map, does it actually work? Can it be, so if you put like raise or hyper, okay, nevertheless. So map, so we map all the elements which are bigger than the current maximum. Right, so yeah, and again we have this assignment, otherwise. And then we grab the defined thing. So the defined will grab elements which happen to have these branches executed, right? Yeah, I don't quite cannot read it. I can understand the idea behind the solution. And actually, I solved it in my program in C++ as well. But it's, probably. And after that, you just reverse the array in place and print the result. Okay, let's run it. It's really an interesting solution. Raku, Colin Crain, Raku Ch 1, and this built-in input. Right. Good. So it works. Good. Okay, we can go next. Our next solution is by Jaldhar Vyas. His solution is here. Ooh, nice. Maybe I want just to run it. And I believe that I want... what do I need to... So I believe I need these, right? Right, 10, 7, 6, 1. Okay, so let's look at how it works. So, yeah, maybe syntax highlighting is a thing that can help. Maybe we can go here and yeah, it's spelled 6, but no, not much is highlighted. Okay, so args, right? So where is okay? So we're going to print all the arguments, right, joined by comma. That's clear. But we are grabbing something, so we are in so we're basically this is the thing which will define the slice of this input array, right? So how do we do that slice? We take all the indices from 0 to the last, well, to the previous, to the last, right, to the last index of this data element, right? Then we grab it, and we grab it using this condition. We grab if, so we grab using this condition if the current element, so yeah, dollar underscore is an index, right? So because these are the indices, dollar underscore is the index, so we grab if the current element, this is the current element, is bigger than, ooh, really? Really? You can do it like this? Then all the elements on the right side. Wow, I didn't know about that. So wait, Raku, for example, my A is 10, 20, 30, 40, 50. A, like 3, comma. No, this is 0, 1, 2, 3, 4. Okay, so what then this, how does it work, I mean? Okay, there's this one. I don't know what that means. Docs Raku V subscript adverb. Wow. Return the bare value of the element rather than potentially returning a mutable value containing, and silently skip non-existent elements. So there's like these 10s. Okay, we've got first element and it's 10. 0, 4, and 2 is 0, 1, 2, 3. So this is like extra. What is it? Returns only the zeros and the second element. This is okay. This cannot modify an immutable integer. Returns the bare value of the element rather than potentially returning immutable values container. Okay, but how does it apply here? And we grab basically, okay, so but wait, but it worked, right? So it worked. Where was yeah, so this is the correct result, right? So okay. Okay, so what is it grabbing? But it's grabbing like indices, right? Yeah, indices, and after that we subscript these, right, using this condition, right? Okay, right, like this. Okay, so yeah, here we have indices for which we have this condition true, right? And this condition is that the current element, the element at the current position, is bigger than all the elements of these elements, right? But I mean, this is what I don't understand. So this is what we have, right? I mean, will this work? Okay, let's run this. Raku, T Raku, and some input, the same input as before. Voila. No, this is not the what? Okay, this is not the not the correct code. It's 78, right? Yes. Yeah. So the result is correct still. So you don't need this comma. And what if use of uninitial value? Okay, so this is the last element and this is the okay, so basically no, so this is incorrect. So this comma does nothing, right? So yeah, I thought that it will give you all the things. Okay, I was confused. Then what if, for example, so basically it tells us if all the elements, so if this is 11 but this is like this is 7, this is 11, 7, 11, right? So 10. Okay, so yeah, we only compare the element to its closest neighbor. So this one passes the condition, but actually 10 is not a leader element anymore because we have a big element, right? Okay, yeah, so yeah, okay, so but nevertheless, this one I don't know, maybe probably there are more. Yeah, KV, it's P. Okay, so yeah, okay, good. Going next, Julio de Castro. I think I didn't see this name for a few weeks at least. Right, so the leader element is the function get leaders. We have a signalless variable a, right, as an array. Oh wow, that's cool. So where is the result? So we basically define a few subroutines. After that, we check if there are no elements, then return 0, right? And after that, in double, so what's that? I believe this is what is it? Is it kind of reduction operator with something inside? Or not? Reduction. Can it be reduction of reduction? Right. Okay, let's see. Just okay. So add leader. So add leader. I believe this should be. So this is the thing that will be returned right after we call the function. So it will give us. I believe this will give us an array of something. I don't know. So empty array and oh my god, what's that? Vertical and hat. Basically, right. So vertical and hat. Hat, I believe, will give us the index, right? What if I will do it like this? Raku. The solution is already so difficult that I cannot quite understand that. So this thing gives us, right, so this is like we had before, like for this, right? So this is the same thing. But this thing is, right, this is basically the array of all those indices which can subscript, with which you can subscript the original data. Okay, so basically you've got the indices here. Okay, list, you've got the list and position, the placeholder variables. This one goes first. This is basically this one, and positions are this. So you flat this. There's nothing here, but I believe you are calling this one. No, you're not calling this one recursively, right? As lead is only. No, yeah, okay. So this is inside the reduction operator, right? So it will be applied in between. Ooh. If leader at this position, then flat. So if leader, if it is a leader, then you take the current one, right? The current one. Yeah. So this one I understand. So you're taking the current one at the element at the position, at the current position $I. Well, yeah, the placeholder variable. Basically, this is the first variable that is passed to this function. Basically, this is the position is here, right? And this is returned. Otherwise, you return an empty array. An empty list. This one is returned if this element is leader, going next, is leader is, so either it's the last element, in which case this is satisfied. Basically, the index is the last thing. Again, this is a placeholder, so this is the first. This is the only placeholder here, so this is the only variable, and the first variable, which is the argument of this function, is last. Right, so either the element is last, we return true, right? Or it's the leading element, right? Okay, so the leader is either the leading element or the last element. And finally, the leading element here is if the current position is bigger than the following elements, starting this position, and the following elements is basically the slice. No, oh no, everything was so good, but I believe this is, again, we're comparing the thing with the next element, not with all the next elements. But in any case, would it work or not, the solution is really interesting. It's kind of, basically, it's a functional solution, right? Straightforward functional solution. Maybe that's fine, because we are enrolling this as a reduction operator, so we will put it in between the elements. So maybe I don't quite understand the double square brackets here, how they work. So okay, let's go, and Raku, Julie, Raku ch 1. So we need, we don't need anything, just run this. Yoo-hoo, this works. Okay, now I want to make a separate test with the difficult case when this element is bigger than 10, but it's not the next element after 10. Right, Raku T. Okay, so this one, so like all following, right? All following is bigger, and basically this is right. This is potentially the solution, right? Okay, cool. Yeah, so yeah, now we fix the solution, and it is beautiful now. just take your homework and explain the double brackets here. Okay, really good. I really like this. So let's go next. Laurent Rosenfeld, Raku number 1. Here is the solution. So there are a couple of sample arrays from the description. So for all of them, that's by the way also a really nice, interesting pattern in that you can use in Raku. So just, yeah, you have 2 arrays, you can just loop over them, and on each iteration you got a regular array with the correct sigil. Yeah, so very simple. All right, nevertheless, so the result, we're gathering things which we then, so we're gathering from the end. And right, so we're taking the maximum. So the maximum is the last element. We are always taking the maximum, that's correct. And after that, so with the whole thing, we are taking the maximum if it's bigger than the current maximum. Right, so we are scanning the array from right side to the beginning, and we're taking the maximum if it's bigger than all the elements, all the maximums that we saw before. Right, okay, right, let's run it. And to run it, we don't need to input to enter anything. Raku Raku ch 1. Right, 10761, and here is only 5. Right, so good. The next solution is by Markus Holzer, and I believe this is something interesting. Alright, so we're reading the integers from the command line. We're printing the leader elements, and the leader elements is the, so there are like 3 different versions, right? Recursive, filtering, and yeah, the best. So, right, so we're reversing it, and, yeah, so we start with the last element, and it's not that straightforward. So max but true if this is, because we need this true even if it's 0, right, if I'm correct. But this is grep, so we need some true thing. So we are taking the thing if it's bigger than the maximum, but we assign, it's similar to what we saw before, but unlike the ternary operator that we used earlier, here is a different construction, which is really interesting. Right, we then grep, and finally we reverse the thing. Reverse, right. Okay, so with the recursive call, what we do here is this function sub, function find. And right, so we are gathering, finding this stuff within the stuff, and we take the element if it's bigger than all the rest, and after that we repeat the procedure for basically for the rest. And to you see, so that's an interesting pattern as well. So this is kind of again a functional programming. So we're taking the element, but we take, wow, that's cool. I think that's the really good thing that you can employ. So you pass the data to a function, but this data is split between two variables, the scalar, and basically the rest goes to an array. So you've got the header element and the tail. All the rest things are here. That's cool. Okay, finally the filtering procedure. So we are grabbing through the indices, right? So these are the indices. We saw that a bit earlier. We grab in if the element is bigger than all of those, and then we just map them back to the values, right? Okay, let's run this solution, and maybe Raku, Markus Holzer, Raku 1, and we need some data. Where can I take it? Like here. Right, the result is correct. Good. Mohammad Anwar, Raku number 1. So again, so Mohammed is using the string as the data, and then leader elements, right? So first we split it into items, then we have these arrays, we map them to integers. Good. Leader elements, we are collecting the things by pushing the elements to the array, and we are scanning the element, and if the element is the last one, we push it, and otherwise if it's not the last thing, and we increment the index, which was 0 in the beginning, and we push the element, if it's not the last thing, in the array, if this element $n, actually $n is the number, it's not the index, right? If it's bigger than the maximum of all the rest, that's also possible. It's not necessarily to use all, but maximum is also a thing, a possible thing. Probably these and these can be replaced by hats before and after these two dots. Right, then let's run this solution. Mohammad Raku 1. Oops, yeah, there are more. By the way, did I take a look here? Yeah, there's nothing else. Okay, so yeah, so the solution by Mohammad Anwar gives the correct result, which is good. And we can go next. Here is the code. So we're taking the data where all the data is integer. Yeah, so that's, you see, so there's the role. We've got this array. We apply the role leader element to that, and after that we can call the method on it. That's by the way, the short example, really interesting technique. I'm not sure that you have to do it like this in this example, but nevertheless, this is the very powerful thing. You can just take a built-in type and append, basically mix in some functionality to it. Okay, so get leaders. So yeah, I see. So don't skip this Unicode character. This is the operator which will apply all the things basically to the array, right? Because self is already this array. We'll apply this method int, and if there are some elements, or if the element is no, so if elements is bigger, wait, or return, right, so if this is true, we do not execute this one. If this is false, so basically there are less than 0 or 0 elements, basically if there are no elements, then we return the list containing 0. Right, the current leader is -1 plus the minimum, so yep, assume the first element, first leader, so which is a bit less than the real minimum. Then we scan from the end, and yeah, /n, yeah, sigil is parameter which is bound to the element. If the current leader is less than this one, the current leader is taken, right? So yeah, it cannot be in the first iteration. Then, yeah, basically you take this, you assign this current clinger, you cache this. Ooh, do we really need that? And otherwise an empty, then we reverse the list. Okay, so yeah. But yeah, the interesting thing is really how this role is applied, is mixed into this solution. Right, let's run this. Jeon go right Raku 1. So again, I need the data, and the result is correct, and I believe it will work for everything because we start from the backside, and right, we find the maximum. The next solution is by Roger Bell West, Raku number 1. And what we see here is we see here two tests for the two arrays from the example of the task, and the functional leader, which takes the array, which reverses it immediately, and then it scans through the array basically from back to the beginning. And if it's not defined, like, yeah, if m, I believe this is kind of maximum, right? Or if c bigger than the maximum, we reassign this maximum and we collect the result to the output. After that, we return and flatten this, and yeah, basically we get result. Good. Raku Roger Bell West Raku 1 built-in examples, they work. Finally, the example, the code, the solution by Ulrich Rieke. Here it is. So where do we start? We start here. So we ask to enter the array. So yeah, basically this is a procedure just to enter the array. What we do, we print some prompt, and this prompt will return you a string, a line, and -1. So yeah, we ask to enter -1 if you want to stop. Then we push the data and prom next number, blah blah. After that, we remove non-unique elements, and after that we can find the leader elements. So lengths of the array, right? So for so lengths -1 is the index of the last element. Lengths -1 is the leader of the element before the last element, right? So we have this, right, because we have this. Yeah, you can use $colon V, right? We saw that before. Okay, so if this element is bigger than maximum of the slice that covers all the elements to the right side, we just push this current element, and after that we push the last element. Yeah, we just want to skip this one because, yeah, we can just unconditionally add the last element to the leaderboard. Right, Raku Raku 1. Okay, so yeah, we need to enter this 9, 10, 7, 5, 6, 1, -1, and the result is correct. Yeah, that was it. So it was the last solution of this week's challenge. It was really interesting. There were a few solutions that are really interesting with functional style programming, for example. So that was week 78 solution to the task number 1, leader elements. Okay, see you really soon. Goodbye.